Variables, Level 1. Algebra and mathematics in general is a symbolic language. Your ability to read these symbols and your commitment to learn a new mathematical language will determine your success in algebra. In addition, remember that algebra builds upon itself. So if you don't feel confident on a specific concept, do not proceed until you have mastered it. You need to learn how to walk before you can run. In other words, don't rush into doing things until you know how to do it. Alright, let's learn about variables. Let's say that you recently got hired as a math tutor at your local tutoring center. Your current hourly rate is $12 an hour. The amount of money you will receive depends on the number of hours that you work. Let's create a table with one column representing the number of hours that you worked, and another column with your pay rate, and the final column representing your total payment. If you don't work, don't expect to get paid anytime soon. So if you work for 0 hours, multiply that by your pay rate, you get 0 as expected. If you work for 1 hour, you will receive $12. For 2 hours of tutoring, you will receive $24. 3 hours, you will get $36, and with 4 hours of tutoring, you will get $48. Not bad. Tutoring math pays off. Alright, notice that we can continue finding out the amount of money we will receive by following the pattern. It turns out that your total payment has a consistent pattern. Specifically, the total payment is equal to the pay rate times the hours worked. In algebra, we can represent this expression as follows. 12 times h. The letter h stands for the hours shown in the first column of the table. In addition, h can stand for other hours not in the table, like 5, 6, and even 80 hours. In algebra, we call the letter h a variable. A variable is nothing more than a symbol, usually a letter of the alphabet used to represent one or more numbers. That's all they are. The numbers that are represented by the variables are called the values of the variable. An expression that contains variables such as 12 times h is called a variable expression. If we decide to let h represent a number, let's say that we decide to let it equal to 4. Our variable expression now becomes a numerical expression. Notice that we have nothing but numbers in our expression. That is to say, the expression does not have any variables. It only contains numbers, hence it is a numerical expression. In algebra, the most common and overused variable is the letter x. Let's go back to our variable expression, 12 times h. If we decide to use x instead of h in our variable expression, it will look like this. This does not look right. Which one is the variable, the first x or the second x? Because of this reason, the symbol for multiplication needs to be changed. Now that you're in algebra, the appropriate way to indicate multiplication for numerical expressions is as follows. We use a raised dot that is slightly bigger than a decimal point. In general, products that contain a variable are usually written without the multiplication sign. Again, because the multiplication sign looks like the variable x. For variable expressions, the way we denote multiplication is as follows. 12 times h can be written as 12h. Likewise, a times b can be written as ab. 1/2 times x can be written as 1/2 x. Start getting used to writing multiplication in this way for variable expressions, and with a dot for numerical expressions. Let's go back to our numerical expression, 12 times 4. This seems obvious, but another way of writing 12 times 4 is by writing 48. What I want you to notice is that in algebra, there are different ways to represent the same number. 48 can be expressed as 12 times 4. Since both 12 times 4 and 48 have the same value, we use an equal sign to symbolically show this relationship. So we write 12 times 4 equals 48, and you read this expression as 12 times 4 equals 48, or 12 times 4 is equal to 48. Another way of reading this expression is 12 times 4 is 48. Either forms are acceptable ways of reading this expression. Okay, now what if I were to ask you if 12 times 3 and 30 have the same value? That is to say, are they equal? Obviously, they don't have the same value. 12 times 3 is clearly 36. So the correct way to express this statement is by using the does not equal symbol, and rewrite it as follows. The way we read this is 12 times 3 is not equal to 30. At times, when we are trying to compare numerical expressions, we need to simplify the expression into its simplest value. For example, if we are trying to compare the numerical expression 12 times 2 and the numerical expression 6 plus 3, we need to simplify each numerical expression to properly evaluate them. The left numerical expression simplifies to 24, and the right simplifies to 9. Both numerical expressions are now written in their simplest value. Now we can compare them. And it turns out, without a doubt, that these two values are not equal to each other. At times, a numerical expression can have more than two mathematical operations in its numerical expression, like the expression 36 divided by 6 plus 8. Notice that we have a parentheses. The parentheses shows how the numerals in the expression are to be grouped. The expression within the parentheses is simplified first. In this case, we first simplify 36 divided by 6 because it's grouped with the parentheses. The result is 6. Then we add 8. The numerical expression is simplified to its simplest value of 14. Alright, now let's go back to the variable expression. Say we have the variable expression 10 times a, or 10a for short. Remember that the variable, represented by the letter a, represents one or more numbers. If we replace the variable in the variable expression by a given value, and then simplify, we say that we have evaluated the expression or found the value of the expression. For example, say that we are asked to evaluate the expression 10a if a is equal to 5. What we want to do is to substitute or replace the variable a, usually with a parentheses, with the numerical value they want us to evaluate with. In this case, the number is 5. Doing that gives us the following, and simplifying the numerical expression gives us that the final answer is 50. In our next video, we will go over a few examples. Variables, level 2. Alright, let's jump straight into some examples. Tell whether each statement is true or false, and explain your reasoning. 7 times 5 is equal to 20 plus 15. Alright, so the first thing we need to do is we need to simplify each side of the expression to be able to compare them. The left-hand side simplifies to 35, and the right-hand side simplifies to 35. Since 35 is equal to 35, this is a true statement. How about the next statement? 3 plus 3 does not equal 3 times 3. Once again, we need to simplify each side of the statement in order to appropriately compare them. The left-hand side simplifies to 6, and the right-hand side simplifies to 9. 6 does not equal to 9. This is true. Let's try the next statement. 4 times 0 is equal to 0 times 6. Again, we need to simplify each expression to appropriately compare them. The left-hand side simplifies to 0, and the right-hand side simplifies to 0. And it turns out that 0 is equal to 0. This statement is absolutely true. Alright, let's try the next statement. 8 divided by 1 does not equal 1 divided by 8. Like always, we need to simplify each side of the expression. The left-hand side simplifies to 8, and the right-hand side simplifies to 1 over 8. So the statement simplifies to 8 does not equal to 1 over 8. And this is once again true. 8 does not equal 1/8. How about the next statement? 54 times 1/2 does not equal 54 times 0.5. We need to simplify each side of the statement to compare them. The left-hand side simplifies to 27, and the right-hand side also simplifies to 27. Remember that the decimal 0.5 can be rewritten as 1/2. So the statement simplifies to 27 does not equal 27. This is absolutely false. 27 does not equal 27. 27 actually equals 27. So this statement is false. Alright, now let's work on simplifying numerical expressions. Simplify the expression, the quantity 8 minus 3 plus 3. The expression in the parentheses is simplified first. So doing that, we have that 8 minus 3 is equal to 5. And we add 3 to the result, which simplifies to 8. Alright, so let's simplify the expression 5 times the quantity 11 plus 1. Once again, the expression within the parentheses is simplified first. So we have that 11 plus 1 is equal to 12. And then we multiply that by 5, which is equal to 60. Alright, let's try the next expression. 6 plus the quantity 12 divided by 3. We worked with the parentheses first, so we get that 12 divided by 3 is equal to 4. We add that to 6, which is equal to 10. Try the next one. 29 minus the quantity 0 times 9. 0 times anything is always equal to 0. So that this simplifies to 29 minus 0, which is equal to 29. Alright, let's try the next example. Simplify the quantity 12 times 10 minus 2 times 11. So here we have an expression with two parentheses. So the left-hand side reduces to 120, and the right-hand side reduces to 22. And now we subtract these two quantities. And now we have 120 minus 22, which simplifies to 98. Let's try the next one. Simplify the quantity 40 divided by 10 divided by 1 times 4. So here, once again, we simplify the expressions within the parentheses. So the left-hand parentheses signifies to 4, and the right expression within the parentheses signifies to 4. So now we need to simplify 4 divided by 4, which is equal to 1. Now let's practice evaluating expressions. Evaluate each expression if x equals 1, y equals 2, and z equals 3. Notice that we have 3 different variables, and each variable has a corresponding value. The goal is to use these expressions to substitute the values of these variables into the following expressions. Okay, so first expression is 5x. The variable here is x, so we need to substitute x with the corresponding value. In this case, it's equal to 1. And always, we use parentheses to substitute any variables. This is going to be key as we work with more complicated algebraic expressions. So now we evaluate the expression. So 5 times 1 signifies to 5. Let's try the next variable expression, x times y. So once again, we substitute each variable. In this case, we have 2 different variables, x and y. So x is actually equal to 1, and y is equal to 2. So substituting expressions, we have the following. And now we simplify the expression, and it turns out that it's equal to 2. Let's try the next variable expression, 3y minus 6. So here, notice that we have a parentheses. We need to work on these expressions first. So first of all, we need to substitute the variable, in this case y, with 2. And as always, make sure you use parentheses when you're substituting. So now we have 3 times 2, which signifies to 6. And then 6 minus 6 is equal to 0. Let's try the next expression. The quantity 3 times z minus the quantity 4 times x. So here we have 2 parentheses. We need to work on each one before we subtract them. So first of all, we need to substitute z with 3, again using parentheses, and substitute x with 1. Left-hand side signifies to 9, and the right-hand side signifies to 4. Subtracting these 2 values, we have that the final answer is equal to 5. Let's try the next expression. 1/2 times the quantity z minus x. We need to work with the values in the parentheses first. So we substitute each value, and we have 3 minus 1, which is equal to 2. And then 2 times 1/2 is just equal to 2 over 2, which reduces to 1. Let's try the next expression. Simplify the quantity z plus y over z minus y. We substitute each variable with its appropriate value. So we have the quantity 3 plus 2, which is equal to 5, over the quantity 3 minus 2, which is equal to 1. 5 over 1 reduces to 5. Let's try the final variable expression. Simplify the expression 8 plus the quantity 9 times x times y, or 9xy. We need to substitute the variables with the appropriate value. In this case, x is equal to 1, and y is equal to 2. So we evaluate the quantity in the parentheses first. That expression simplifies to 18, and we add 8 to that. So we have that the final answer is equal to 26. Alright, in our next video, we will learn how to simplify expressions with and without grouping symbols.